Good day everyone, I present to you a design project conducted by myself, Gift Matebula and Sizwe Dumezweni, whereby we were instructed to construct a device that measures density. The densities of 3 liquids were tested and obtained through using the relationship between kinematic viscosity, dynamic viscosity, and density. The liquids tested include hair conditioner, dishwasher, sunflower oil, and water. Water was used to calibrate the devices in order to calculate the required constants for the equations presented in the report. Our apparatus includes the mentioned liquids to be tested, a tube and syringe to measure the dynamic viscosity, a bottle with an orifice at the cap to measure the kinematic viscosity, and a stopwatch. The kinematic viscosity, the efflux time was recorded 3 times and an average was used to calculate the kinematic viscosity. Shear rates and shear stress were used to compute the dynamic viscosity of the fluids. The time recorded for each fluid to flow through the tube was used to calculate the shear rate. To evaluate the effects of temperature, the experiments were conducted during the day and during the night. During the day, the temperature ranged between 24 and 25 degrees, and during the night, the temperature ranged between 15 and 16 degrees. During the night, the fluids were poured into plastic containers and placed outside for at least 3 hours to account for the temperature decrease. The results obtained indicate that the densities of the fluids were higher during the night and lower during the day. This supports the relationship between viscosity, temperature, and density. The relationship states that a decrease in temperature will result in an increase in viscosity and an increase in density. The table of results in the appendix indicate that the dishwashing liquid had the highest density, followed by the hair conditioner, and the lowest density was observed in the sunflower oil. The experiment was efficient in presenting the differences in density amongst the tested fluids. However, the experimental values that were calculated were inaccurate. The experiment was also able to present the relationship between temperature, viscosity, and density efficiently, as the results obtained indicate that a drop in temperature results in an increase in density. In addition, a floating test was used to support the results obtained from the experiment. As you can see, the densest liquid is at the bottom.